With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Everyone, let us solve this question. The question says that for negative deviation from Raoult's law, which of the following thermodynamic relation is incorrect? Option 1, delta G mix less than 0. Option 2, delta S mix greater than 0. Option 3, delta V mix greater than 0. And option 4, delta H mix less than 0. So in this question, we have to find out the incorrect thermodynamic relation for the negative deviation from Raoult's law, right? So first of all, we'll see what happens in negative deviation. Suppose we are forming a mixture of two components. Now what happens if we take two components A and B? If the force of interaction between AA molecules and BB molecules is less than the force of interaction between AB molecules after forming the mixture, then what happens? The vapor pressure pressure which will be observed for the mixture, it will be less than the ideal vapor pressure, right? Now, because since force of interaction between AA and BB is less, force of interactions between AA and BB is less than the force of interaction between AB. It means after forming the mixture, there is strong force of interaction between the molecules. Right. So when there will be strong force of interaction between the molecules, their tendency to get vaporized will decrease. Ultimately, vapor pressure which will be observed for the mixture, it will be less than the vapor pressure that should be there for ideal solution, right? So such solutions are known as non-ideal solutions because vapor pressure is less than the ideal vapor pressure. Now here we are getting negative deviation from Raoult's law. Now what happens if we see the thermodynamic relationship for negative deviation? So first of all, in option 1 it is given delta G mix less than 0, right? So we know that for a feasible or you can say spontaneous process, delta G is always less than 0, negative. And we are mixing the two components, which is a feasible process. So delta G mixing will be less than 0. This is the correct relation, right? Then in option 2 it is given delta S mixing greater than 0. Now entropy change is greater than 0. This will also be true because we know that according to second law of thermodynamics, the entropy change of universe will always be greater than 0. There is always increase in entropy, right? There is never decrease in entropy. So whether it would be a negative deviation or positive deviation, entropy will always increase. So it will be greater than 0. Then in option 3 it is given delta V mix greater than 0. So it is saying that change in volume after mixing the two components will be positive. Now basically in the resulting solution, right, there are strong force of interaction, there is strong force of interaction. Now due to strong force of interaction, the molecules will be closer to each other. Now when the molecules will be closer to each other, volume will decrease. Volume will decrease. Will decrease. Now it means after mixing volume is decreases. For negative deviation, then delta V mix will be less than 0 because volume is decreasing after mixing the two components, right? So here option 3, this thermodynamic relation is incorrect for the negative deviation. Then in option 4 it is given delta H mix less than 0, right? So as you can see, before mixing the components, there is weak force of interaction between AA and BB molecules, right? But after forming the solution or you can say mixture, we have strong force of interaction between the molecules, right? So strong bonds are formed. For the formation of strong bonds, energy will release, right? For the formation of strong bonds, heat will release, right? If heat will release, it means the process is exothermic. Since the process is exothermic, so enthalpy change of mixing will be less than 0. It would be negative, right? So this is the correct relation. So incorrect relation is delta V mix greater than 0. So here option 3 will be the answer. Option 3 is answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.